Good morning everyone, back to our channel. So today before that, please like the video, share the video to your friends, subscribe to our channel, click the bell icon for getting notification of all the videos. So and please comment your suggestion, opinion and doubts in the comment box. So without much ado, today now this is the last part of all organic reaction series, that is amines and nitrogen compounds. Amines and nitrogen compounds. Okay, this is a simple chapter. This chapter don't have very much weightage and all, not as weightage as aldehyde ketone, but it has weightage compared to ethers. It is what important. One question can be coming from this chapter, not directly, maybe connected question. So first of all, we have preparation. First one is reduction of nitro compounds. So take a nitro compound. So I am just taking nitrobenzene. Okay, and I am reducing it with what, H2 palladium or platinum in ethanol medium. Then what I get? This will be reduced to the corresponding amine. We are getting aniline here. We can also reduce it using other reagent too. That is, I am taking the same compound to reduce. You can reduce any nitro compound, or basically any nitro compound. I am taking nitrobenzene and I am adding SN, that is tin plus HCl, or you can add Fe plus HCl. Then also you will get aniline. In this three methods, the preferred method is using Fe plus HCl. This method is preferred. Why? You know that when Fe plus HCl is used, this Fe and HCl will form a compound, that is FeCl2. Okay, got it? FeCl2. Okay, this compound hydrolyzes, and we get HCl. So if we use very less HCl, initially if we are using 1 gram HCl, finally you may get here also 1 gram, so totally 2 gram HCl is in the medium, and forward reaction boosts according to Le Chatelier's principle. That way Fe plus HCl is preferred reagent. Okay, yes. Now next method is, this method and all I have explained what very detailedly in our amines video that I posted 10 or 15 days ago. So please watch it for more clarification. Now ammonolysis of alkyl halides. It's very simple. The same reaction we did in the carboxylic acid chapter also. No, this is not same reaction. This kind of reaction. We are taking Rx and we are adding NH3 to it. What happens is that this lone pair of NH go and attach to this R because it is electropositive. This X again electronegative. So finally what we get is RNH3 plus X minus substituted ammonium salt. Into this substituted ammonium salt, RNH2 NH3 plus X minus. If I am adding NaOH, what happens? We get the corresponding primary amine, RNH2 plus NaX plus H2O, corresponding primary amine. Okay, now if I am taking this corresponding primary amine, into this corresponding amine, this reaction we did in haloalkane halorine, that what reaction is this? Substitution reaction. This is called nucleophilic substitution reaction. Now into this amine I am adding an Rx. Nucleophilic substitution take place in this Rx and we get what? We are taking R dash X. Okay, No, you can take the same Rx itself. Okay, we are once again adding the same Rx, this compound, okay. Into this, what happens is that we get secondary ammonium. No, secondary amine. Now into the secondary amine, once again I am adding the same Rx. We get tertiary amine. Okay. Into this tertiary amine, I am once again adding Rx. This is tertiary amine. Into this tertiary amine, if I am adding once again, I am adding Rx. We will get Rn. We'll write it together. That will be simple. R for N plus and X minus. This is called quaternary ammonium salt. The problem of this reaction is that, look, first of all, we are having one amine. We got primary amine as a product. If there is Rx in the medium, once again, if Rx in the medium, this will join together and some of the compound will be transformed to what? Secondary amine. If there is more Rx, it will be. So when we are adding Rx to the secondary, it becomes tertiary. Into this tertiary, if there is some Rx left in the compound, we get what? Quaternary salt. The problem here is that we are getting a mixture of products. To stop this mixture of products, what we should do is that we should limit the quantity of Rx. If there is excess Rx in the medium, only this Rx can be used for preparation of secondary, tertiary and all. Limit Rx and use excess of NH3. So all this Rx will be in NaOH medium. All this Rx will be converted to the corresponding primary amine only. This is suggested for getting what? Only primary amine. Okay, this is the reaction with ammonia or ammonolysis. Now third one, next method is reduction of nitrile, that is cyanides. Here we get RCN is there. Into this we are adding the reducing agents H2Na or NaGC2H5. It's not NaG, sorry, NaG, sodium amalgam, plus C2H5OH, ethanol, or you can use lithium aluminium hydride also. Aluminium hydride, what you get? You get RCH2NH2 as the compound. Here look, here this compound had one R group and a cyanide substituent group. Here look, the cyanide group changed to CH2. So here we got one carbon more than starting compound. So to get one carbon more compound, use this method. So this is reduction of nitriles. Now next method is reduction of amides. We use this reduction of amides. Reduction of amides. Very simple. Directly take an amide and use a lithium aluminium hydride. Lithium aluminium hydride only can do the same. No other reagent is given in your book. So lithium aluminium hydride and hydrolyze it. You get the corresponding amine. Sorry, once again. You get the corresponding amine, not RNH2. You will get RCH2NH2. Okay. This is the reaction. Okay, got it. Now fifth one is important named reaction. That is Gabriel phthalimide synthesis. So preparation of phthalimide is given in your carboxylic acid chapter. I hope you have seen the same. What is phthalimide? This compound is called phthalimide. NH C double bond O NH. This compound is called what? Phthalimide. Into this compound add KOH. Add KOH. So this H will be escaping and we get the compound as C double bond O N minus OH N plus OH minus, sorry, N minus, not OH, what I am doing here, N minus K plus and the this thing. Now into this I am adding a RX. This R will be the alkyl part of the amine that we needed. Okay, we are adding RX, so we get C double bond O N R plus the left will leave as KX. Now into this compound, that is N-alkyl phthalimide. N-alkyl phthalimide, I am adding NaOH, not alcoholic but aqueous NaOH. I get C double bond O minus Na plus, C double bond O minus Na plus our main compound, that is the primary amine. This method can be only used for preparation of primary amines. Only used for preparation of primary amines, and note, only aliphatic primary amines. Aliphatic primary amines. If you are trying to prepare aromatic amine, problem is, what is the problem? Problem is that I'll draw aryl, that is AR. Aryl X bond is having a what character we learned? Partial double bond character. So due to this partial double bond character, what happened? It is difficult to break AR X bond. So therefore nucleophilic substitution. Gabriel phthalimide synthesis is what reaction? It is a nucleophilic substitution reaction. Nucleophilic substitution. You know that aryl halides don't undergo nucleophilic substitution reaction. Only one reaction we learned, that with NaOH in extreme condition. Here no extreme condition. Here we are not using NaOH also. So this can't break. So we cannot prepare aromatic amines from the method, from this method. Okay, this method is over. Now next method is Hoffman bromamide degradation reaction. Hoffman bromamide degradation reaction. Okay, so this method is also used for preparation of primary amine. Aliphatic and aromatic can be prepared. Primary amine only can be prepared, aliphatic or aromatic, depending, or aromatic, both can be prepared, no problem. Okay, so this reaction is that take an amide is our reactant, take the corresponding amide, add Br2 plus 4 NaOH. The thing is that we are getting one carbon less, we are getting not RCH2NH2. This is not the compound that we are getting, this is not the compound, we are only getting RNH2 plus Na2CO3 plus 2 NaBr plus H2O plus 2 H2O. Okay, so here we are getting one carbon less amine. In using nitriles we got one carbon more amine. Here in bromamide synthesis we are getting one carbon less amine. This is the reaction, just learn it. So by this preparation methods come to an end. Next one we have the chemical reactions. that is one basic character. You know that amines are basic. We have learned in reaction mechanism. That is amines can react with the acid, that is HX, any acid. What happened? We get RNH3 plus X minus. What? Substituted ammonium salt. So we are getting the corresponding salt. Okay. So this is a salt. So you know that this is an acid base reaction. Acid base reaction. So we get a salt. So this is an acid base reaction. That's why we are telling amine is a basic compound. Amine is a basic compound. Now the basic character of amine is explained very largely, but what I am going to tell now is I am just going to explain it very simply. I told that, you remember, electron withdrawing group directly proportional to acidic character. This means it is directly proportional to 1 by basic character or inversely proportional to basic character. Electron donating group directly proportional to inversely proportional to acidic character. Okay, so that means it's directly proportional to basic character. Okay, this is it. Look, I am taking an aliphatic amine RNH2 and ammonia and the aniline. In these three compounds, here look, here there is an R group donating plus psi effect. You know that electron donating group comes, basic character increases. So here it is most basic. We will just write it is most basic. Look at NH3. NH3 is having 3 hydrogen atoms. One second, I will draw it in the proper structure. NH3 is having 1 lone pair and 3 hydrogen atom. The problem is that here there is no plus psi effect, no minus psi effect, because hydrogen is deaf and dumb. It will not do anything. This is just like a what? Hydrogen is just like what? A person who is invisible. So here this is more basic. We just write this is more basic. This is less basic than this aliphatic amine. When we come to aromatic, usually phenol and all was more. Aromatic character increases. And one more thing we are going to write here. Aromatic is directly proportional to acid character and inversely proportional to basic character. If aromatic, a compound become aromatic, mostly the compound will be what? Less basic. Here why it is becoming, this is for sure less basic. This is the least basic in the given compound. Why this is least basic? That explanation is just to take that compound. This is that compound NH2. Okay. Here the resonance will happen. Okay. The problem happening here is that lone pair is delocalized. So the lone pair of the compound is what? Delocalized. You know that base means what? Base means what? Electron donor. Here what is happening? The electron which ammonia already had it, or amine and nitrogen already had it, which should have been shared, which should have been increasing the basic characters, now inside this what? Partial double bond. Now it is this is the minus charge. This is in conjugation. Ortho nitro para conjugation. Here it is at what? Conjugation. Here it is at conjugation. So therefore the electron is not available for forming acid base bond. So what is happening? Basic character is decreasing. So when we are considering these three, aromatic is least basic, then ammonia, then most basic is amine. Acidic character was directly opposite. ROH, we took H2 over there, and aryl phenol. It was like this, but here the order is opposite. Okay, yes. Now I want to ask you, RClOH, RCl, NH2 and RNH2. Which one is more basic? Yeah, this one is more basic. Why? I told you that electron withdrawing group comes, basic character decreases. Here Cl is there. electron withdrawing group, therefore basic character decreases. Okay, yes, so note this. Now I am taking aniline, and also I am taking aniline is here, nitroaniline is here, and para-toluene aniline is here, NH2 CH3. Which is more acidic? Which one is more acidic? Ortho, nitro or para? Electron withdrawing group come. This is electron withdrawing group. Basic character decreases. So this will be in the third, least basic. Now this is an electron donating group, EDG. So this will be in the first place. This don't have any group, so this will be in the second place. So this is order will be 1, 2 and 3 basic character. If they ask the acidic character, this is basic character. If they ask the acidic character, or if they ask the if they ask the acidic character, then write it as 3, 2, 1. Least acidic is 1. Okay, simple. Yes, so this is what is told about the basic character. Now they are explaining the same thing once again. Okay, now the thing is that here one thing is important. That thing is important thing. Just by heart the order. Just now you just by heart it. In gaseous phase, when the compound is gas, you understand that, you know that 3 alkyl group is coming means it is what? Tertiary amine. This one is secondary amine. This one is primary amine. Among this, which is most basic? Yeah, this is most basic. Why? More plus A effect. This is second basic. So here only 1 plus A. Here 2 plus A effect. Here 3. So most basic is tertiary, then secondary. So in gaseous phase, the basic character is like tertiary, secondary and primary. But in aqueous phase it is different. The reason is solvation effect. You just learn in aqueous phase for methanamine, for 1 carbon amine only, the order is different from all other carbon amine. For 1 carbon amine, that is CH3 NH2, and when 2 CH3 is coming, so these compounds, the order is different. Just write this. That is CH3. Here secondary will have the first preference. Secondary will most acidic. Then we expect what? The order for gaseous phase is tertiary, secondary, primary. Here it is very different. That is, it is secondary, then tertiary, then primary, last only we are having what? Tertiary here. Okay, 1 carbon amine. For 2 carbon amine and more, the order is different. Here what happened? Here the order for 1 carbon amine, the order was secondary, primary and tertiary. For 2 carbon and more, that is from ethanamine and onwards, the order is C2H5OH. There also secondary is always first rank holder. In aqueous phase, secondary is first rank holder. But if there are 2 carbons, here 1 carbon. In first standard, what happened? First rank holder is always secondary carbon. Second rank holder was primary and third rank holder was tertiary. In second standard and above and all other classes, what happened is always secondary is the first rank holder. But from second standard onwards, tertiary started learning the subject very well. Chemistry 100, physics 100. In second standard, no physics and chemistry, every subject 100. So from second to unlimited carbon, what happened? Tertiary became the second rank holder. And primary was upthrown or underthrown to its third rank. So So learn this. Okay. Yes. So this is the order. Now let us. I am taking a few minutes break. Someone is outside. I'll come now. So that's about so that's about this reaction. Next one is alkylation reaction. Very simple. We learned in haloalkenes chapter. What's the reaction? Rx plus R dash NH2 gives us R NH R dash plus HCl. This is the reaction. Just learn this. Very simple. No need to explain that much. Next one is acylation reaction. That is I'm taking an amine. That is C2H5NH2. Okay, into this I am adding an acid chloride. Okay, what's happening here? This double bond will go and join here, and oxygen will pull one of its bond. So what's happening here? Yes, here we get C2H5N HCH3 Cl O minus H, this thing, and this end is having a positive charge. Okay, now what happened? This minus charge falls here, falls back. This hydrogen will leave here, giving its electron to nitrogen to remove the positive charge. So if this double bond is forming here, chlorine more electronegative, I tell bye, and it will cut and it will go off. So what we get is C2H5N NH C double bond O CH3. We get N-ethyl, once again E is capital, N-ethyl methanamide, N-ethyl ethanamide. This is the compound we are getting. Okay, this is the reaction for formation of amide. Okay, one more we will do like the same. That is C2H5NH C2H5 plus CH3 C double bond of Cl. This is carried out, I forgot to write here. This is carried out in presence of base. The condition is that base should be stronger than amine. Why we should use a base here? Look, after this reaction we are getting HCl as one product. This base will remove this HCl, and according to Le Chatelier's principle, if product is removed, if product side is decreased, what happened? The reaction tries to increase the product side. Therefore, the equilibrium or the reaction shift rightwards. That's the reason. Why we should use a stronger base than ammonia? If a weaker base than ammonia is used, ammonia itself, ammonia that we took here, this ammonia itself go and act as a base and neutralizes HCl. So we don't get the enough reactant for creating the product. So for stronger base is used, stronger base will go and neutralize the HCl. That's the thing. Okay. So we are telling about this reaction. In presence of base, usually we use pyridine or any strong base. Comparatively, you can use nitrogenous base, so that way we are using pyridine. Okay, pyridine. So what is happening here? Yes, simple. C2H5N C2H5C double bond O CH3. This is the compound we are getting. This is the compound is NN diethyl ethanamide. NN diethyl ethanamide. So now different combinations you can try and you will get the answer. Okay, look, they have written another thing, that is CH3NH2 plus benzyl chloride. No, benzoyl chloride. What are we getting? We also do the same. First of all, we should draw this compound, that is CH3. CH3N H C double bond O and the benzene ring. So this is the compound we are getting. This is called N-methyl benzanamide. This B is small term. Benzanamide. N-methyl benzanamide. This is the compound. Okay, this is N-methyl benzanamide compound. Now acylation reaction comes to an end. So like this, you can try different combination. You will get different product accordingly. Okay. Yes. Next reaction is carbylamine reaction. Carbylamine reaction. What is this reaction? Take a primary amine. This reaction is only work for primary amines. Only work for primary amines. Take a primary amine, add CHCl3, chloroform plus 3KOH, and heat it. Then we get a foul smelling gas. That is, the smell of the gas is very foul smelling. Means if you have ever smelled what is that thing, I can't explain it, a very bad smell, a foul smelling gas is evolved. Okay, 3KCl plus 3H2. This is the problem. A foul smelling gas is evolved. This gas is called as isocyanide or isonitrile. Isocyanide. This gas is foul smelling. Okay. Yes. So this is a test. We are getting carbylamine. This isocyanide is also called carbylamine. So we are getting carbylamine as a product. That way we are calling it as carbylamine reaction. Okay, perfect. Over. RNH2 plus CaCl3 plus KOH. We are getting the foul gas. This reaction is really used for distinguish between primary amine and secondary or tertiary amine, because secondary and tertiary amine don't give this reaction, only primary amine give. So if we need to differentiate between primary amine and secondary or tertiary amine, you can use this reaction. Use this carbylamine reaction. Okay, this is over. This reaction is over. Now next one is a reaction that is very important, because this reaction we are going to learn a second part of this lesson is there, that is diazonium salt. There also this reaction is important, that is the reaction with nitrous acid, formation of diazonium salt. Okay, so first of all we will be doing aliphatic compound. I am taking an aliphatic primary amine. Okay, and I am adding HNO2. Presence of NaNO2 plus HCl, we are getting a compound like this, N2 minus N2 plus and which HCl is here. So Cl minus. This thing is called what? This thing is called, what's the name of this game? Aliphatic diazonium salt. we are getting aliphatic diazonium salt as the product. If we add water to this diazonium salt, we get the corresponding alcohol, that is alcohol N2 plus X. Okay, yes. Now if you are taking aromatic compound and doing the same reaction, that is, I am taking aromatic compound, I am adding why I am writing the same thing here. I am adding NaNO2 plus HCl in 273 to 278 Kelvin temperature. I will get a diazonium. The same reaction we are learning in first chapter. What halorine we learned in this chapter. Which one is alcohol phenol we learned, and now in amines also we learned. Very special reaction, right? So NH2 plus N2 plus X minus. This is called benzene diazonium salt. Benzene diazonium salt. Into this, if we add water also, what happen? Hydrolyzing happen and we get the corresponding phenol. This was a preparation method for watering phenol. Remember? Yes. Okay. Correspondingly we get the product. That's it. Now next reaction is 6. That is reaction with Hinsberg reagent. With the Hinsberg reagent. It's a simple reaction. What is Hinsberg reagent? Hinsberg reagent is this thing. Aryl sulfonyl chloride. That is, this is the compound. One second. Okay. Yes, double bond O, Cl. This is called Hinsberg reagent. Okay. And this Hinsberg reagent test is also a distinguishing test between primary, secondary and tertiary. Very important. Distinguishing test. So what we are going to do first with primary amine. Take a primary amine. I am taking RNH2 and I am adding this Hinsberg reagent. S double bond O, Cl. And I am getting a compound as a product. The product is S double bond O. Let it be there. Remove the Cl and attach this NH. So we get NHR. Okay. This is the compound we are getting plus HCl. This compound is named as N-ethyl benzene sulfonamide. So we are getting this compound. The speciality of this compound is that it is soluble in water, soluble in alkali as NaOH or KOH. Okay. So what I am going to write? Primary amine plus Hinsberg reagent gives us product. Take that product and put in alkali. Pour alkali into it. If it is soluble in alkali. Understand that the amine we took was a primary amine. It's a confirmatory test for primary amine. Now, if I took a secondary amine, that is NHR dash, and I am adding corresponding Hinsberg reagent, that is S double bond O Cl. I am getting S double bond O. Just add the nitrogen R dash R. This is the compound I am getting. This is called N, N dialkyl benzene sulfonamide. The speciality of this compound is it is insoluble in alkali. This compound is insoluble in alkali. Okay, why was the above compound soluble in alkali? Why was the above compound soluble in alkali? Why was it soluble? It is soluble because you know this hydrogen is very acidic, because look, this sulfonyl group is a very strong electron withdrawing group. It's withdrawing electron from nitrogen. Nitrogen is also electronegative, comparatively electronegative. So when this sulfur is taking the electron, this is becoming a very big positive charge. It's not liking it. It is pulling its electron too much from this and giving this a very big positive charge, and this will be positive negative. It will be having a small negative charge. So now this hydrogen is highly acidic. Therefore, when we pour alkali, it neutralizes. But look here. Here what's the thing? There is no hydrogen, only alkyl group. The speciality of alkyl group is that the alkyl group will give its electron. From two sides it's giving. So this nitrogen is not that electropositive. Even if it is withdrawing, this is not electropositive. Okay, that's the thing. That way this is insoluble in alkali. So secondary amine. Now if I am taking an X, some amine X, plus I am adding Hinsberg reagent, I am getting a product which is insoluble in alkali. What is this X? This X is a secondary amine. So for primary amine we get a product soluble in alkali. For secondary amine we get a product insoluble in alkali. For tertiary amine, what we get? Take a tertiary amine. No need of H, R dash, R double dash. And I am adding the corresponding Hinsberg reagents, that is S double bond O, double bond OCl. Okay. The problem is that, look, I am taking the compound, I am just putting the S double bond O, double bond O. I am removing one, I am adding one nitrogen, R dash, R dash, R double dash, R. My God, what is this? This compound is possible. Nitrogen having 4 bond and a plus charge. Here nitrogen is having a plus charge. Okay, this is possible because it can share its electron. Good, perfect. Plus charge. Now this group is electro withdrawing, EWG. Strongly electron withdrawing group. So this is pulling too much. So this positive charge is like a very big positive charge. So this compound is unstable. Therefore, as this compound is unstable, this compound never forms. This compound what? Never forms. So one second. Tertiary amine do not react with benzene sulfonyl chloride. Benzene sulfonyl chloride. So you can write a table for Hinsberg test. One second, let me draw a good table. This looks very odd. Yes. Okay. Amine product solubility in alkali. First one, primary amine product is N-alkyl benzene sulfonamide. You can write it accordingly. Also, let me make this a big table. Okay, one second. I just erase this. One second. Yes. So, amine product solubility in alkali. First one, primary amine. The compound we are getting is N-alkyl benzene sulfonamide. Solubility in alkali, what is it? It is soluble. Due to hydrogen. Now secondary, you get NN corresponding alkyl benzene sulfonamide, same thing itself, and it is insoluble in alkali, no hydrogen. Tertiary compound, no product, no solubility. What if product form only solubility is there, so it is just X into 1. Okay, yes, over, yes. So this is about reaction with benzene sulfonyl chloride. Now next reaction, that is 7th one, electrophilic substitution, because amine is having what resonance inside the conjugation, or especially for aniline only it undergo electrophilic substitution. So electrophilic substitution of aniline or aromatic amine substitution. Okay, you have read lot many things are written. First one is bromination. Look, this reaction only is for what? Aromatic amines. So because there is minus charge in ortho meta para position. And aniline is what group? It is a ortho para directing activating group. So ortho meta para is the places where the compound will attach, not meta. Carboxylic acid and aldehyde was meta group, but aniline is a ortho para directing activating group. Okay, understood? Yes. Now we are having aniline, and if you are adding 3 bromine, if you are adding bromine water, this is called bromine water at room temperature, we are getting vigorously a reaction happen, as in phenol we learned. If you are adding bromine water at ortho meta para position, all together vigorously the bromine going join. But in carbon disulfide, what happened? Only in meta, or only in ortho, or only in para position it joined accordingly. Here what is happening? Vigorously it is going on joining all the 3 positions. This is called 2,4,6 tribromoaniline. Okay, this compound is formed, plus 3 HBr is the byproduct. Okay, yes. The main problem encountered during this is the reaction is very reactive. So if we need to get only ortho substituted aniline or only para substituted aniline, what should we do? Take this aniline, take the aniline, and add an methyl anhydride in a base, that is usually pyridine we use, pyridine medium. What we get? We get a special compound NH. 1H is replaced by C. Here it is NH2. I wrote NH3. Here NH2. So one hydrogen is replaced by the C double bond of CH3 group from the anhydride. Now into this we are adding bromine in acidic medium or in acetic acid. Acidic medium or acetic acid. Bromine only gets substituted at the desired position, that is para position. Not ortho, it is para. So para position bromine gets substituted. And now if we add hydrolyze it, what happened? The above thing vanishes, that we get NH2 above and Br at the para position. We are getting our desired product for bromoaniline. So first aniline, treat it with the anhydride, we get a compound. This compound, they can ask, what is this compound form? Okay, the name of this compound is acetanilide. So learn acetanilide. Structure is very simple. Take an aniline, replace 1H with what? C double bond or CH3, acetanilide, or N-phenyl ethanamide. Acylation, with using acylation reaction we can prepare this compound. Just in acylation, how to prepare this? How to prepare this? Take amine NH2 plus take what carbonyl compound? We will take CH3 C double bond or Cl. Like this also we can prepare the above compound, I think. It is NH C double bond O CH3. Okay. Yes. So this is the limited addition of bromine. Okay. Now B is nitration. Addition of nitrogen. So here the reaction is special. Aniline is protonated. Okay. 1 second. Yes. So when we are taking aniline, if aniline is protonated, that is one H is added, we get this compound, that is NH3 plus. Here plus charge is here. So what happened here? Also a special type of resonance is happening. This will go here, it will come here. Here plus charge. So at ortho, meta and para position plus charge is coming. So ortho, meta and para position, what? Plus charge is coming. Charge is coming. So plus charge is ortho, meta and para position. Right. Is it like that? No. Thing is that you understand, here only 1,3 resonance happens. Mostly 1,3 resonance happen. So what happens is that, look, we have the protonated compound. It's very untidy. I'll draw it tidy. Here we have NH2 plus 2. Sorry. So one more hydrogen we added, we got positive charge. This will come here, plus charge will go here. You think that this will come here and plus charge will go here. This reaction doesn't happen. Only 1,3 resonance is happening. Okay, 1,3 resonance is happening. You understand that. So what's happening? Here, ortho position is electron deficient. So therefore ortho substitution, electrophilic substitution at the ortho position is very less. But meta position has more electron density. Because the group is meta directing. Anilinium ion is meta directing. Okay. Therefore what happens when we this is only applicable to nitration, not applicable to bromination. Only for nitration this anilinium ion case is happenable. So HNO3 H2SO4 and 288 Kelvin, we get 3 products. One is ortho, one is para, meta also you get because anilinium ion is a meta directing group, plus ortho. Here ortho will be only 2%, very less. Ortho will be very less because I know electron density is ortho position. There is electron density because of what? Resonance inside the aniline. When there is resonance, there is minus charge at ortho position. But when we get anilinium ion, it's not there. Here first of all we are having an acid H2SO4. Here what? Protonation happens, then only NH3 plus NO2 is going to add. Therefore here only 2% yield is there. But meta position we are having a high yield of 47%. As usually para position is the major product, that we are having 51% yield. Okay. So here the second major product, the minor product is ortho, major product is what? which one is para, but 47% this product is also formed. Meta product is also formed. So now if we wanted to create only this look very untidy. If you wanted to create only you want to add NO2 in the para position, as we did in bromine. We want only 4 bromoaniline. As like that, we want 4 nitroaniline. For that, you do the same method we did, add acid anhydride, and first make the compound into what? Acetanilide. Make the compound into what? Acetanilide. Do it. In pyridine medium, we get what? Acetanilide. Acetanilide, that is NHC double bond O CH3. Into this acetanilide, we are adding what? HNO3, H2SO4. H2SO4, the temperature 288 Kelvin. You get, and first you add this, then hydrolyze it. You get the corresponding NH2 and para substitution nitro group. You get para nitro or 4 nitro anilide. Okay, this is about nitration reaction. Now we have C, sulfonation. Take aniline and H2SO4. As H2SO4 is an acid, here acid base salt formation happen, that is NH3 plus SO4 HS, not SO4, HSO4 minus, a fault is formed. Anilinium hydrogen sulfate. Heat this 450 to 470 Kelvin. You get sulfa-anilic acid. That is at para position, you get sulfa-anilic acid, that is SO3H. The thing here is, this is acid, this is base. Acid and base is coming in same ion. If acid and base is coming in same ion, here an effect happens. That is here an effect happen. That is Zwitter effect. Due to Zwitter effect, here an effect happen, that is Zwitter effect. So what happened, inside this compound itself, acid base neutralization happen, that is SO3H, and we have NH2. This hydrogen from this SO3H go and attach here. So we get a Zwitter ion. We call that neutralized ion, or the ion that is created due to acid base reaction inside one atom. We call them as Zwitter, that is NH3 plus and SO3 minus. This ion is called Zwitter ion. And there is an important thing in biomolecules chapter. You learn that amino acid is a Zwitter ion. Why? In amino acid there is amino group and acid group. So therefore it acts as a Zwitter ion. This thing in biomolecules chapter you will learn. Here is the thing where Zwitter ion is explained in your textbook. In biomolecules they are just telling acid base reactions going and Zwitter ion is formed. This is called what is called Zwitter ion. Okay, yes. Now understand a note. Aniline don't have Friedel-Crafts reaction. Why? You know that carboxylic acid don't give, we told the reason, Friedel-Crafts reaction. But aniline don't give Friedel-Crafts reaction. Why? Because aniline is a base. And AlCl3, the catalyst used, is a Lewis acid. base, acid. Instead of acylation or alkylation happening, here what happened? This Lewis acid and Lewis base will neutralize to form salt. So here, when we try to do Friedel-Crafts reaction, the catalyst go and attack the reactant and forms a salt. So therefore, Friedel-Crafts reaction don't happen in aniline. Okay. Yes. Now, amines part come to an end. The next part is diazonium salt part. Diazonium salt. Okay, diazonium salt. What is happening here? First of all, preparation. You know how to prepare. We have learned in the above reaction. Diazonium salt. Look, I will tell you something. Aliphatic diazonium salt. Salt is unstable. They fastly hydrolyze to alcohol. So we are only going to learn about aromatic or benzene diazonium salt here. So preparation of diazonium salt. Take aniline, add NaNO2 plus HCl at what temperature? 273 to 278 Kelvin. You get the corresponding diazonium salt, N2 plus X minus, and rest reagents, that is NaCl plus, here NaCl we are getting, if you are using HCl, NaCl plus 2H2O. Here we can use 2HCl if it's like that, because we need 2Cl, right? So this is the product. This is called, why this is very untidy, I'll write it tidily. One side it became untidy, I don't know why. Yes, this is called benzene diazonium salt. Okay, only one method is there to prepare this. This method is called as diazotization. Enough. Now chemical reaction. This one is important. This one is comparatively important. Okay, chemical reaction, and only very less question from this part also will be asked. But Sandmeyer's reaction and Gattermann reaction is important here. First one, Sandmeyer reaction. You know the same reaction. I am not explaining it because I already explained it. You are having the diazonium salt. Into the diazonium salt, three different reagents can be added to get different products. If you are adding Cu2, Cl2 and HCl, you get corresponding haloarene. If you are adding Cu2, Br2 plus HCl, you will get corresponding bromoarene. What is this called? Bromobenzene plus nitrogen. If you need, you can also add CuCl, copper cyanide, in presence of KCN. Then you will get ArCN, that is benzene cyanide or benzene nitrile plus nitrogen. This is the reaction, Sandmeyer's reaction. Now second one is Gattermann reaction. Not Gattermann-Koch, it's just Gattermann reaction. Just Gattermann reaction. Ar, that is An2 plus X minus. Into this add copper plus HCl, add copper plus HBr, anything. If you need ArCl, add copper plus HCl. you will get this products. This X is Cl and here you get ArBr plus nitrogen plus CuBr. So this is Getterman reaction. I already explained this in the haloalkane haloarine part, so not explain much. Just this reaction you learn. It's not like by hearting. You should understand that somewhere you see this reaction, you should understand that this is Getterman-Koch reaction, we should get haloalkane. This is Sandmeyer reaction, we should get haloalkane or cyanide. You should just understand that. That's it. And they can also directly give this reaction as the name of the reaction, or they can give the name of the reaction and options can be what the reactants or products. For that you learn. That's what I have to tell you. Now next one is iodine replacement. The reaction with Ki, just put some diazonium salt in a bottle and Ki and shake it. After that you will get what? The corresponding iodobenzene. Yes, right. So take diazonium salt, add Ki, you get Ari plus KCl plus N2. This is the reaction. Now next one is fluorine replacement to form fluoride, that is fluorobenzene. Fluorine replacement. For fluorine we use KF, no. We use CuF, no. Cu2F, no. Cu plus HF, no. For fluorine, the reagent we use is HbF4. Okay, HbF4, that is fluoroboric. Name of this thing is fluoroboric acid. The reaction I have already explained in haloalkane haloarine. Refer the video. I will be just writing it and telling a few words. Take about diazonium salt, add the HbF4. Now what happened? No, this chlorine is replaced. The chlorine is replaced by An2 plus BF4 minus plus HCl. We are getting HCl here. Now we heat the same. We get ArF plus N2 plus here you have BF4 plus BF3. These are the products. So we are getting fluorobenzene. Next one is 4. Hydrogen replacement, that is formation of alcohol. Hydrogen replacement. There are two reactions. No. Hydrogen replacement, not formation of alcohol, formation of benzene. For forming benzene. Important. Ar, N2 plus Cl minus. Take the diazonium salt. You can add H3PO2. What is H3PO2? Hypophosphorus acid or phosphinic acid. Hypophosphorus acid or phosphinic acid and some water. You get the corresponding hydrocarbon plus nitrogen plus H3PO3 plus HCl. Okay, this is the thing. You can use H3PO, that is a hypophosphorus acid. Instead of hypophosphorus acid, you can also use ethanol, that is plus C. So take this aryl, what's this thing called? Sorry, sorry, 1 second. I took just a break. Someone called me, so I just got distracted. So take the diazonium salt. Into that you can, instead of adding H3PO2 hypophosphorus acid, you can add ethanol. Then also you get the corresponding hydrocarbon N2 plus CH3 CHO. Here we are getting what as byproduct? Aldehyde as a byproduct. Here we got H3PO3 as byproduct. Here we got aldehyde as a byproduct plus HCl. That's it. Now fifth one is replacement by hydroxyl group. That is replacement by OH. Very easy reaction. Warm with water. we learned it before, a few minutes before, right? Few minutes before. Take the compound, that is diazonium salt, add water and warm it. You get the corresponding hydrocarbon N2 plus HCl. Okay, simple reaction. Now replacement by sixth one. Replacement by NO2 group. NO2 group. This is N2 plus Cl minus plus HbF4. Here also we use HbF4. Now what we get? Normally what we used to get when we had HbF4, that is N2 plus BF4 minus. This thing we got when we did for fluorination also. If we just heat this compound, we get fluoride. If we add NaNO2 and copper into this compound and heat it, we get the corresponding NO2. The compound is NaNO2 and copper. NaNO2, copper, you get NO2 plus N2 plus NaBF4. Okay, yes, this is the reaction. So these are the basic reaction. Basic reaction means reactions where the halogen atom is removed. Halogen atom is removed. But now I am telling about some reactions or some important reaction, that is coupling reactions. How to do coupling reactions? First of all, just it's very simple. If they ask any coupling reaction, take the diazonium salt, that is N2 plus X minus. Perfect. Now add. Now take if they are giving alcohol, take alcohol and put the para portion of alcohol facing with the N2X and alcohol here. Now in basic medium what happened? This X go away and you just join it together. That is N. There are 2N, so 2N, and this hydrogen also going away. Hydrogen also is going away, and we are getting OH. This is what happened here. Two compounds coupled together, and this is a orange dye. So this is a coupling reaction, usually are called diformation reaction or azo dye reaction, where dyes are formed. This name of this dye is para hydroxyazobenzene. That is para hydroxyazobenzene. This is an orange dye plus Cl minus plus H2O. Okay, add it accordingly. Now we are using doing the same reaction with another reagent, that is you have N2 plus X minus. Instead of phenol, we are taking aniline. So I told the para hydrogen should be facing like this. Now remove these two away. We get N double bond N NH2. This is a yellow dye. Name of the dye is para amino azobenzene. It's an orange dye plus corresponding Cl minus plus H2O you are getting. Okay. Only these two coupling reactions are there in your book, so we'll just learn this two. Learn the color. If it's phenol, it's orange color. If it's amino group, it's yellow color. That's important. Name of the compound to do. Okay. Yes, this is about what? Diazonium salt. By this, all the reaction of diazonium salt gets over. So this is about coupling reaction. So by this, all the reaction of diazonium salt also got over. Now we are having a portion that we kept pending, which is that is alcohol, phenol and ether. Ether portion we didn't do. So now we will be also doing ether portion, ending all the organic chemistry reaction. So we don't have to take a long time. Now we'll be doing ether. This ether is not that important, but questions have been asked from Williamson synthesis and all. So you should learn that portion. One, first of all, preparation. One, from dehydration reaction. Dehydration of alcohols. You know that when we dehydrate alcohol, we get alkene. Then how is this possible? Look, we have learned that in about alcohol chapter, that if you dehydrate an alcohol, I'm taking an alcohol and I'm dehydrating it with the concentrated H2SO4. What happened? At specific temperature, 443 Kelvin. For 43 Kelvin, I am getting CH2 double bond CH2. Then how they are telling that this reaction will lead to the preparation of what? Ether. Thing is that we will get ether. Use same reagent but lower the temperature. Instead of 443, keep the temperature, reduce the temperature, how many? 30 degrees Celsius, and keep it 413 Kelvin. That's 413 Kelvin. 413 Kelvin. Then instead of what? Ethene, we get the corresponding what? Ether. That is CH3, CH2O, CH2, CH3. This is ethoxy ethane. We get ethoxy ethane. So this is a reaction. If temperature is very high, dehydration happens. If temperature is comparatively low, what? What reaction happens? Etherification, not etherification. Ether formation will happen. This is about dehydration of alcohols. Now second part. Second part is Williamson synthesis. Very simple. Take an alkyl halide and take what? RONA. That is RO minus Na plus. That is sodium salt of what? Alcohol. And react these two together. What happened? Here you are taking R dash. If you are taking R dash, okay. RO R dash. And this resting will be leaving as NaX. This is called Williamson's synthesis. This is the one of the main reaction for preparation. Look, in this reaction, the most important part to note is, I'm giving you an example. Take this CH3 ONA, this compound, plus CH3Br. Here this is primary and this is tertiary. If the alcohol salt is tertiary and the haloalkane is primary only, the reaction will proceed. Always the degree of alcohol salt, understand, degree of alcohol salt should be greater than degree of haloalkane for Williamson synthesis. Understood? Yes, this is the important thing. This reaction here, it is primary, tertiary. Tertiary greater than primary, reaction happen. How it happens? We'll write the product. No need of byproduct, we'll just write the product. CH3 O CH3. This is the product. But instead of this, if I took this thing, CH3 CH3 I Br or anything plus CH3ONA. Here what salt of alcohol is having primary and alkyl halide is tertiary. I told that always ONA degree should be greater than Br's degree. Here it is the opposite way. Therefore, this reaction proceeds through another product. A product will be formed, but the product is very different. The product is CH3. This Br will be removed. Here dehydrohalogenation reaction happen. That is CH2 CH3 one product, and the next product will be NaBr. This Na will be leaving with this Br. They are in love. They left NaBr, and when one hydrogen is left here, right? The hydrogen that left from this carbon, this hydrogen go and join here and forming alcohol, CH3OH. This is the reaction that's gonna take place. If we use degree of alkyl halide is greater than degree of ONA. Okay. Yes. So this is the Williamson synthesis reaction and the exceptions. Now if we need, we can convert phenol also to the corresponding phenoxide by this method. We can also prepare anisole by the Williamson's method. That is, take OH. You know that. Take OH plus NaOH. If you do this acid-base reaction, you get the corresponding sodium ONA O minus Na plus. Into this add RX. Primary only we can add. Don't add secondary, tertiary. It will result in other compounds. Because this is primary, then you can only add primary. This can be equal also. Both the things can be equal. Primary and primary can be added. If you are adding tertiary salt and primary this alkyl halide, that's also possible. That's also possible. Correspondingly, what we get? We get O and R. This is called. Okay, we get the corresponding. If this compound was this thing, that is, here we got CH3. This compound is called anisole. Common name is very important for this compound. Anisole. Over. Yes. So by this, preparation methods are only two are there. Now chemical reactions. Cleavage of CO bond in ether. CO bond in ether. That is this bond. CH3 CH2 oh my god, what am I writing here? CH3 O CH2 CH3. If I am cutting this bond, that reactions are being discussed here. Okay. Take an ROR, that's an ether, plus HX, you get RX plus ROH, R dash OH. R dash OH or R dash X plus ROH correspondingly. Okay, corresponding. And reaction of this HX, that is HI is more reactive than HBr than HCl. Okay, this thing you note. Now let us write the compound. Let us write the combinations. We are having a compound CH3. What is this? Yes. CH3OCH3 plus HI. Here this can break like this and form CH3 CH3OH and CH3I and this big OH, or the other way around. It can break here and form the compound. You know where it will break? it will break here, because oxygen always prefer smaller groups. Oxygen always prefer smaller groups. Understand that. And we get the compound as CH3, 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 I plus CH3OH. Or you understand that there is a carbocation formation intermediate happening. Carbocation formation intermediate happening, and this carbocation or this carbocation is stable, this carbocation is stable, tertiary. This is primary, so tertiary is more stable, hence I go and join them. You understand it in these two ways. These two ways. Okay? Yes. Now let us do some example for these questions. Let us do some example for these questions. I will ask you, this is a compound, in this compound add what? Nothing to add. In this compound add HI. What happens here? The compound breaks like here OH. I told you that here plus come or here plus come, which is more stable? Oxygen plus charge, never stable. No, not oxygen plus charge. Here phenyl plus charge, not stable. But here this benzylic carbocation, very stable. So therefore we get CH2I and the benzene group. This is the compound form. So form the compounds like that correspondingly, you will get the answer simply, easily. Okay? Yeah. Now next set of reaction, that is electrophilic substitution. Look, you know that the anisole and all, or any aromatic ethers are activating and orthopara-directing. Therefore orthopara position, this will fall here. Here negative charge, here negative charge, here negative charge. Therefore electrophilic substitution reaction will happen. First set of reaction is halogenation. It is not vigorous as in alcohol and the in amine. It's a slow reaction, not slow, a limited controlled reaction. Br2 in ethanol. Ethanoic acid medium. We get this is anisole. So we are using anisole here. Any aromatic ether can be used. We get this as major product, that is para as major, and always ortho will be minor. Ortho as I will draw the ortho here. Ortho as minor. Okay. Yes. So this is halogenation of ether. Now nitration. Normal method of nitration. Just take the compound OCH3, add corresponding concentrated HNO3 and H2O. HNO3 and H2, what concentrated H2SO4. Correspondingly, what happened? In ortho position and para position, NO2 go and add. NO2 in para position major. NO2 in ortho position, what? Minor. Simple one. This is a simple one. Minor. This is minor. Now next set is what? You know that Friedel-Crafts reactions. Friedel-Crafts reaction. One alkylation. Take an RX. Take the ether first. We are taking anisole itself here, and into that add corresponding RX. CH3. Not, I will just write it commonly, so that will be simple. That will make it easy. RX. Presence of anhydrous AlCl3 in CS2 medium. We get OCH3R. This is minor or in para position. OCH3R. This major. Okay, yes. Now third reaction. Now next one is acylation. The spelling of acylation is wrong. Sorry. Acylation. OCH3 H2SO4. Sorry, this is I'm right. Once again I wrote nitration. What corresponding RCOCl plus anhydrous AlCl3 in CS2 medium. You get what? Ortho substituted CH3. This thing as minor is ortho and OCH3 C double bond OCH3. This as major. Okay, completed. So by this all the organic chemistry from part 2 textbook have been done. Now hydrocarbon we will be mostly not doing because all the reactions that we did today are the most important. Hydrocarbon is like there in between everything. So ozonolysis, HGSO4, in hydrocarbon dehydration and all, there is same thing is there in hydrocarbon. So we will be not wasting time for that. But we wasted our time. We utilized our time for doing all the organic chemistry chapter. So hereby we completed haloalkenes, haloarenes, alcohols. This is completed. Now alcohols and phenol, and next one aldehyde and ketones, carboxylic acid and derivatives, amines and nitrogen compounds. These 5 compounds. Last but not the least, ethers. These 1, 2, 3, 4, 5, 6 portions with preparations and chemical reactions and physical properties, important physical properties and important points have been completed, and hence the all organic chemistry reaction session come to an end. Thank you for watching. Thank you for watching the video. Please like, share, subscribe and comment your opinions. Thank you.